SQL, structured query language, and NoSQL, not only SQL, are two distinct approaches to managing and retrieving data within modern database systems. Each has its own set of strengths and weaknesses, catering to different use cases and requirements. We will now compare SQL and NoSQL databases, highlighting their similarities and differences.
Similarities. 1. Data storage. Both SQL and NoSQL databases store and manage data, facilitating data organization and retrieval. 2. Data integrity. Both types of databases ensure data integrity, with mechanisms to enforce constraints and rules on the stored data. 3. ACID compliance. Many SQL databases adhere to ACID, atomicity, consistency, isolation, durability, properties, which guarantee robustness and reliability in data transactions. Some NoSQL databases also support ACID transactions, although not all. 4. Indexes. Both SQL and NoSQL databases offer indexing mechanisms to improve data retrieval performance by enabling faster search operations.
Differences. 1. Data model. SQL databases use a structured, tabular data model where data is organized into rows and columns, making it well suited for data with fixed schemas. NoSQL databases embrace various data models, including key value, document, column family, and graph. This flexibility accommodates unstructured and semi-structured data. 2. Scalability. Traditional SQL databases tend to be vertically scalable, where hardware upgrades are required to handle increased loads. Horizontal scalability is achievable, but often more complex. NoSQL databases excel at horizontal scalability, allowing them to distribute data across multiple nodes or clusters, making them more suitable for handling large amounts of data and high traffic. 3. Schema flexibility. SQL databases have rigid schemas requiring predefined table structures. Altering the schema can be challenging and often requires downtime. NoSQL databases offer schema flexibility, allowing changes to the data structure without major disruptions. This is particularly useful in rapidly evolving projects. 4. Query language. SQL databases use the standardized SQL language for querying and manipulation, offering powerful querying capabilities for complex operations. NoSQL databases may use proprietary query languages specific to their data models. Some NoSQL databases have less sophisticated querying capabilities, but newer versions have improved this aspect. 5. Consistency vs. Availability vs. Partition tolerance, CAP theorem. Traditional SQL databases prioritize consistency and often provide strong transactional guarantees. This might lead to reduced availability during failures. NoSQL databases often lean towards availability and partition tolerance, sacrificing some level of consistency in favor of system responsiveness and fault tolerance.
In conclusion, SQL and NoSQL databases serve different purposes and excel in various scenarios. SQL databases are well suited for structured data with defined schemas and strong transactional requirements. NoSQL databases, on the other hand, are flexible and scalable solutions that thrive in scenarios involving large amounts of unstructured or semi-structured data and dynamic schemas. The choice between SQL and NoSQL ultimately depends on the specific needs of a project, including data complexity, scalability demands, and performance expectations. Thanks for watching, and see you soon.